Hello, in this video, we're going to take a look at the first step at how we actually represent the graphical representation of the data. More specifically, we are going to learn how to plot histogram on the data, and we're going to learn how to plot bar and whisker charts on a specifically given data. And later on, we are going to move into the discussion of measuring central tendency and variance in our data set. All right, so let's get started with our data set. So we do have baseball salaries data, and it goes all the way back to 2012. But we are on the tab of 2018, and we will be primarily working on this worksheet. All right. Um, in the first column of this data set, we are given the name of the player, and then their team, position, and their salary information, and how many inputs we have. If you go all the way down to the bottom of the data, you see that we do have 877 different players and their teams, their position, and their salary information given to us already. Um, Okay, so if you have this information and maybe you are wondering, okay, what does this salary look like compared to, well, what does the salary look like in the entire league or the data that you have already in your data set? Histogram is a very nice, very insightful way of looking at the distribution of the data. How we can get histogram on Excel? It's easy. Go to Insert and click on this statistical charting section. And on the very first one, you'll see that you have the histogram here. Okay. It brings up the distribution of your data sets along with the bins. Okay, I will enlarge this. When I say bins or the intervals, I'm referring to these numbers. So as you can see, the first bin is composed of the salary starting at $545,000 all the way up to $2,845,000. It looks like we have more than 500 players in this category. In the second category, the minimum value and the maximum value is allocated like this, and it looks like we have almost like 100 players in this category. So as you increase the salary information, of course, the number of people who in this higher salary categories is going down. If you, for example, look at this one, you see that we have only 17 salaries here, right? So there is another way of deriving your histogram here. If you again select your salary column and you go all the way up and you click on insert histogram, the second version with the Pareto chart, it will bring up another level of discussion to you. And what it is going to tell you is this. On the right axis, so it brings up another axis, another y-axis to histogram. The blue bars are identical to what you see here, but this red line is telling you how much percentage is belonging to corresponding category. So for example, almost 65% of the entire players' salaries belonging to this first category, right? That's what you see here. And then if you move up, if you go towards right, at the very end, it is going to be adding up to 100% for sure. But let's say you are trying to have some sort of cutoff. I think this is like 85%. 85% of the categories are belonging to the first three categories, right? You can easily say that from this Pareto chart. Okay, so histogram is nice. What can we say about the shape of this data, right? what do we see? We don't definitely see a bell curve like a normal distribution curve here. We do see a curve with a very long right tail. And this is what actually I'm referring to. If we can get any symbols here. Okay, so let's get some shapes out there. All right, this is just going to be perfect. Okay, I'm looking like this. Right, this data looks like it has a long right tail. Okay, so we are going to see how we can detect this long right tail in a moment by using different techniques. But we can also tell this by visually inspecting the histogram, right? What else we can do? We can definitely do a bar chart on, sorry, we can definitely do a box and whisker chart on the entire salary. Let's do that. Let's go to insert one more time. Under the stats tool, box and whisker plot. And I'm just going to do this. Oh, it changed the histogram. Oh, I didn't want that. Okay, I want to do it extra. Okay, let's go all the way up. Insert post and whisker chart, and my histogram is right here. Okay. So what do we know about box and whisker plot? We know that. Well, actually, let me go scroll to the right and tell you more about box and whisker chart. So it's a very nice way of visualizing different segments of your data. It is very helpful when a person is trying to identify outliers in the data. What it does give us is the first person, or minimum data and the maximum data first. For the leftmost data, or at the bottom data in your box and whisker plot is going to be your minimum data, minimum point in your data. In our case, it's going to be the minimum salary in our data set. And then the rightmost is going to be the maximum value. Okay, we do have the first quartile being represented as the leftmost edge of the rectangle, okay, that we have, or the box that we have in our box and whisker plot, or the box plot. Some people call them box plot. And then the second quartile is going to be our median, and it is going to be highlighted in our box as well. And the third quartile is going to be the rightmost edge of the box. Okay. What this third quartile mean, for example, is it is equivalent to saying 75th percentile, right? The number of data sets that's going to be less than this number, or third quartile, is actually the probability that's going to fall into this region is actually 75%, right? That's what this 75th percentile mean. Second quartile is actually 50th percentile, and the first quartile is 25th percentile. Okay, interpretations are identical. Interquartile range is calculated as, well, actually the distance between the third quartile and the first quartile. It's basically Q3 minus Q1, right? And how you find the outliers is dependent on the interquartile range, okay? For example, this minimum, this leftmost corner of this line is connecting, that's connected to the leftmost side of the box is referred to as, there's not a specific name of this one, but anything below towards the left of this edge of the corner of this line is referred to as outliers, right? Potential outliers. All right. So the way that you calculate this leftmost edge of this line is based on the interquartile range. And how you do it? It is Q1 minus 1.5 times IQR. IQR is Q3 minus Q1. Similarly, on the right side, you do have potential outliers because you could calculate this rightmost corner of this line based on the interquartile range. This time it is going to be Q3 plus 1.5 times interquartile range. And interquartile range is Q3 minus Q1. And anything greater than this point can be a potential outlier, right? Why do we say potential outlier? Because we never know. Um, we never know whether these points are going to be our outliers because we don't know the future, right? Sometimes in a year or two, those might be our regular points, right? So that's why we say potential outliers. We run our analysis with them and without them to see if we have any better representation of the data, okay? But that's one way of identifying outliers. So let's take a look at our Bucks and Whisker plot for the baseball players. We don't see any bottom outliers, but we do see a lot of outliers here. These are potential outliers. So these salary information, well, let's see, $35 million. You see $30 million, $20 million, $15 million. Well, if you look at the median, you see this line right over here. I think the median is maybe 1 million, 1.4, $1.45 million, right? I think that's what it says. We can't see it that much, but that's what it says. So this cross is basically the average, not the median, but the average. So average is definitely higher than the median. Okay, so that's how you read the box plot. Well, what if you say that, okay, can we do a box plot for each position of the players? We sure can. And the way that you generate it is selecting these two columns and going to insert, and again, the box and whisker plot. So this is, let me cut this and then paste it right below the one I just generated. Okay, let me paste it here. You see that Excel is clever to understand that I am trying to do a box plot for each position. I can clearly see which position is making higher salaries. Well, there are a lot of potential outliers for the outfielders and pitchers. If you just compare their averages, those crosses, all right, those crosses, what you see here is that the average salary is much higher for the designated hitter, okay? What about median salaries? So again, the median of the designated hitter is earning much more compared to others, but I do have a lot of potential outliers or potential high gainers from other positions compared to designated hitters, all right? What if you would like to do box plot salary analysis based on each team? Well, I can still do that. What I see here is my team information is here. Okay, I select this whole column, team column. And since the salary information is not adjacent to it, I hit my comment key and select this salary cell. And now I'm still hitting my comment key. As I'm hitting my comment key, I hit also my shift key, and I'm now hitting my command and shift key, and I hit my bottom arrow to select the other column, right? And then I remove my hands from my keyboard, and I come over here, insert box and whisker plot. Okay, and I think it did give me, I just cut it, and I would like to paste it here. Okay, and it did give me the salary information of my baseball players based on each team. So let's see which team is paying higher salaries. It looks like Los Angeles Angels is the team giving us the high. Well, not really. I do have. Well, actually, if you look at the highest player, yes, I think we need to have the highest paid player is from Los Angeles and Angels, and I do have Dodgers too here. But if you compare their means, you see that the highest mean is maybe here. Well, that is actually a nicer way of analyzing this box on this plot. So if you click on this charting area, right click on it and then go to format data series. If you just click on show mean line, it is basically adding a line that is connecting all the means, so it's much easier to see the highest mean here. I think it is San Francisco Giants. Their means are higher. What else? Can we check their median? Maybe with different colors, it will be nicer to check the medians, but you can definitely check it for yourself. So it's a nicer way of taking a look at your data set, like based on teams and the positions and overall salary information. It's nice. Box and discrete plots are very nice. And it's a very simple way of taking a look at, how your data is behaving. I'd like to show you on the second half of this video. I'd like to show you some of the formulas that I want you to know when it comes to analyzing central tendency and variability. So here if you go to the right spreadsheet, you see that we do have summary measure salaries in 2018. I created this empty Excel sheet for you. When we are trying to look at the central tendency, we compare mean, median, and mode. And I'm going to show you the Excel functions, these central tendency measures. So for mean, it is simply the average, right? So you just type average, and you would like to select the entire salary information here, right? And enter. All right, it will be your average. So what I will do for median, again, it is median. In the parentheses, and go ahead and select the salaries column. Okay, and mode, if you remember, the mode of a data set is the most frequently seen number in the data set. And it is again selecting the entire salaries data. Okay, looks like $545,000 is the most commonly seen salary in 2018 across all teams. Okay, that's what our analysis tells us. Well, if you'd like to do some range analysis, you will have to start by calculating minimum, maximum. And if you'd like to take a look at, for example, the first quartile, second and third quartile, without even plotting a box on Whisker plot, you can still do that in Excel. You can even calculate the percentiles, like the first percentile, the fifth percentile, 10th percentile, 25th percentile. Well, 25th percentile is going to be identical to the first quartile, right? But let's get started. So the mean is simple. So I'm instead of just going back to this spreadsheet and then spreadsheet tab and selecting the entire data set, what I will do is I will just copy one of these functions that I already put together, and I will paste it here instead of median. Now the data set is going to be the same. It is actually min. So if you hit enter, you see that actually the mode is actually the minimum salary that we do have in the salary database. And max is very similar. So instead of median, actually, I will just take it to max. The maximum salary, as we realized on the box and whisker plot, it was around for $35 million. Actually, it wasn't $35 million. It was $34 million. Dollars, $34 million and $63,000. Okay, if you look at the box plot of your data based on different teams, what you see here, you can see, for example, the first quartile for Los Angeles Angels. First quartile is here, second quartile is the median, and third quartile is right over here, right? Well, I don't want to draw these box plots, and I'm going to use the quartiles somewhere else. How do I find them? Well, it is literally Excel function is quartile. Okay, quartile, the entire selection of the data. Well, I'll go back and select the entire salary one more time. And comma, it's going to tell you which quartile you're interested in. Well, I store that information here. I am interested in, it actually gives you the option. If you select 0, it's going to give you the minimum value. If you select 1, it's going to be giving you the first quartile, second, and third quartile. I do keep them here. So I select this cell. Oh, you don't see them. I will just put here for now, and I will tell you what I'm talking about. So I do keep the 1, 2, and 3 here. So I will just come over here and change this one to C9, or simply selecting this cell. Okay, it works. The reason I did it this way is because I would like to drag this down so that I like my formula to be updated itself. But before I do it, again, I will go ahead and hit Command and T to make the selection fixed. And I go down, okay? So it got my second quartile as 1,450,000. You see that it is identical to my median. That is not a surprise because median is the second quartile. Okay, and this is the 25th percentile, and this is the 75th percentile. And you will see that these numbers are going to be equal to 25th and 75th percentile in a moment. What if you would like to calculate the percentile information? And then it is literally just percentile, okay? And then the K, so arrays are going to be coming from my data. Let's go back and select my data again one more time. Comma. Yeah, I don't really like when Excel puts this automatically before even asking me. But let's put 0.01 here for now, because I do store 0.01 here. What I would like to do is go and change the 0.01 to this cell reference C12. That's because I would like to be able to draw this down and like the formula to update itself. Before I do that, I added the dollar signs and I drag it down. It works out just fine. As I said, get the 21st percentile. 21st percentile is actually the first quartile. I do have the same numbers here, right? And 75th percentile is actually my third quartile, and I do have the same numbers here. So 75th percentile, remember, if you look at the data set, 75% of my salaries are less than $6 million. That's how you interpret it, right? Okay, let's take a look at how we can measure certain variability for this data. And range, unfortunately, there is not a function for range, but range of a data set is basically the max minus the min, right? So I can just easily do that here. Interquartile range, remember, it is actually the third quartile minus the first quartile, right? I can calculate the interquartile range here, and you can visually again see it on this picture. Interquartile range is Q3 minus Q1. Okay, and variance. I do have nice variance formulations here. I click on var.s because this is just a sample of the salaries from the basketball league. And I'm going to select the entire salary information one more time. And I'll just close the parentheses, it calculates my variance, and standard deviation is std du dot s. Again, it is coming from a sample of salaries from the league. Selected my data, close the parentheses, and hit enter. Okay, so I could calculate now range, interquartile variance, and standard deviation. Skewness. So skewness is going to tell us whether we do have a long right tail or long left tail or a simple bell curve. Okay, excuse me. Based on this value, let's first calculate it. It is a little skew, and you just need to select the data. Okay, just close it and hit enter. It is telling us that it is actually 2. It looks like if it is positive, if your skewness is positive, skewness number is positive, it is basically telling you that you have longer right tail, and the measure of the tail can be measured by the skewness. And if it is negative, it is actually telling you that you have long left tail. Let's take a look at the histogram of the data, and it is going to prove the fact that we do have a very long right tail, actually, right? Kurtosis, it is simply going to be telling us idea about how condensed these observations are. And let's calculate it. It is current function. And let's select the entire data set. Hit enter. It is basically telling us 4, and it says that if it is greater than 3, it has a high peak. What do I really mean by that? If you actually don't worry about the skewness of the data, the most frequent observation is the highest frequency of your salary is going to be for this group, right? Minimum value being $545,000, and then the highest interval bin here is $2,845,000, right? You do have 534 observations in this range, compared to others very small, right? Kurtosis is actually telling you that you do have a very high peak, right, in terms of number of observations in a certain group. Okay. Can we get most of these observations by using Excel autonomous tool? Yes, we can. As you integrated your data analysis toolpath with Excel, if you go to your data tab, you can look for data analysis toolpath, and then if you click on it, it gives you several options. Select descriptive statistics, okay, and it gives you the option to select your input range. My input range is on my salaries. I will select the entire salary column. Okay, I will manually select them. I will select the entire salary column, including this salary label. And then if you select the first cell, including the salaries label, you want to make sure that you check this box, otherwise it's going to give you an error, just to tell Excel that my first observation in this column is actually a label. I would like this output range to start here. I would like this observation to start somewhere here. I would like to see summary statistics, and if you hit OK, it says that descriptive statistic input range must contain at least one data point. So let's do it one more time. I'm not sure what my error was. But let's go to data analysis one more time. Descriptive statistics is okay. Oh, okay, I see what it means. Input range should be my salaries. Okay. I selected it earlier. I'm not sure why it didn't pick it up. Let's do select it one more time. Okay, this is my entire data. My output range is starting from, yeah, I1. Yep, summary statistic is checked, and I hit OK. Yes, now it worked. What it did is it actually went through my salary information. It calculated my mean, standard error of the mean, median, mode, standard deviation, sample range, scriptosis, skewness range, minimum, maximum, and sum, and then the count information for my salary information, right? Well, sometimes people like to use these Excel functions, and sometimes people will say, yes, this is good enough for us. Excel state analysis, descriptive statistics is just out there for you. If you like to do a quick glance at these basic descriptive statistics. Well, that's all for this video. We will pick it up with some much more advanced version of Excel functions for our data analytics class. Thank you for watching.